Hi, welcome back to Mind Maths with Amna. Today I'm going to solve the sample examination questions given in the Statistics 1 study guide given by University of London for their EMFSS programs. This is chapter 3 called Probability Theory. Okay, so the first question is that the probability of the event B is 0.05. In probability of the event A happening, given the event B has already happened, is a 70%, and the probability of event A happening given that the complement of B has already happened is 0.3, which is a 30%. So let's make a tree diagram to represent this. So either the event B will happen or the complement of this event will happen. So we know that the probability of the event B is a 0.05. Since probabilities of events have to add up to a 1, therefore the probability of the complement of B happening is going to be a 1 minus a 0.05, which is a 0.95. Okay. Then after B, either A can happen or the complement of A. Either A or the complement of A. So the probability of A occurring given that B has already occurred is a 0.7. Which means since probabilities have to add up to a 1, the probability of the complement of A happening provided that B has already happened will be a 0.3. Similarly, the probability of A occurring given the complement of B has already occurred is a 0.3, and since probabilities have to add up to a 1, therefore the complement of A occurring given the complement of B has occurred is going to be a 0.7. Okay, so they want us to find the probability of B given A, and that is going to be the probability of B intersection A and over the probability of A. So we need to find both of these things first. So what is the probability of A intersection B? So in English, verbally, we would say the probability of A and B happening. So that is just going along this route. So this is first B happening and then A happening. So that means that we need to multiply the probability of B into the probability of A given B. So that the answer will become a 0.05 multiplied by 0.7, which is 0.35, I guess. Let me check. I do not rely on my brain for such calculations because I always mess up. Oh yeah, see, I was wrong. It's going to be 0.035. So glad I checked it. Okay. Then what about probability of A? So we know there are two routes at which you can get an A. Either A will come after the event B, or the event A could happen after the complement of the event B has happened. So there's a trick that whenever you see the word and, it is associated with the multiplication sign. And whenever you say the word or, given like there are 2, 3, 4, 5 possibilities, then between the possibilities there's going to be a plus sign. Okay, so there are two possibilities that I get a B and then an A, or there's a chance that I'm going to get a B complement and then an A. Okay, so what is going to be the formulas then? B and A is that B has happened, and then the probability of A happening given B has already occurred, plus probability of B complement happening, and then the probability of A happening provided that B complement has happened. So multiplying the probabilities we've given in the probability tree, this was the first. The second is a 0.05 multiplied by a 0.95 multiplied by 0. Okay, so this was a 0.035 plus, let me take out my calculator, 0.95 into a 0.3. This is a 0.285. When I add 0.035, I get a 0.32. Hence, the answer is going to be 0.035 divided by 0.32. So 0.035 divided by 0.32, and the answer should be a 0.109375. Okay, we can just write it to like 2 decimal places or 3 decimal places. So the probability of B given A is a 0.12. And remember, this is less than 1, so I know probabilities have to be less than 1. If your answer is greater than 1 and you don't have time to recheck the paper, just tell the examiner that I must have made some kind of calculation error, because probabilities have to be less than 1 and my answer exceeds 1, so I made some kind of mistake. So if you don't have time to find the mistake, just state this to the examiner. Okay, question number 2. I'm going to solve 4 questions per video so that the video isn't that lengthy. Okay, next question. An engine encounters a standard environment with a probability of 0.95 and a severe environment with a probability. Okay, so there's a standard environment. Let's just call that, because then if I call this S and I call this S, it's going to be confusing. So let's call the standard environment normal and severe environments S. Okay, so we have 2 options. We have the standard environment and then we have the severe environment. Okay, the probability of the standard environment is a 0.95, and therefore since probabilities have to add up to a 1, the probability of the severe environment is just going to be a 0.05. So even if they didn't tell us this answer, we would have known, because they have to add up to a 1. Okay, in a normal environment, so given that there's a normal environment, the probability of failure, so probability of failure is a 0.02. So the probability of failure given a normal standard environment is a 0.02, and therefore the complement of failure happening, which is basically success, is going to be, since probabilities have to add up to a 1, we are going to write a 0.98 over here. Okay, next, whereas, okay, in the normal environment, the probability of failure is 0.2, and in the severe, it's a 0.05. Okay, so I'm just going to copy paste this here, and the answer to both is a 0.5. Okay, sometimes I like actually defining the probability of N and F happening over here, because I know I just have to multiply along this along the tree, which along these, what are they called? I think they're called nodes. So along these nodes, so a 0. Let me take out my calculator. A 0.95 multiplied by 0.02 is a 0.019. okay, and then 0.95 multiplied by 0.98, which is basically the probability of a normal standard environment, and then failure is ka complement actually is a 0.931. Okay. Okay, now the problem of a severe environment and our machine failing is a 0.05 multiplied by 0.5. So that's a 0.025. And then the probability of a severe environment, 0.05, and the machine not failing is again the same. So severe environment and the machine does not fail is again a 0.025. Okay, so what is the probability of failure? We can see that the machine will either fail when we have a normal environment, or remember, or now that I'm saying or, it means there's two possibilities, so there has to be a plus sign. So either it can fail when we have a normal environment, or it can fail when we have a severe environment. So what do I write? I'll say that the probability of failure is that there are two possibilities, that the environment was normal as in standard, and the machine failed, or so this is or the standard what did it say, the environment was severe and then the machine failed. Okay, and it's important that I actually write the formula that this is equals to probability of normal environment multiplied by failure of machine given the environment was normal, plus the probability of severe environment, and then the probability of failing given that the environment was severe. And we've already actually calculated these over here, so now I just have to add these, right? So I say a 0.019 plus a 0.025, and then our answer becomes a 0.044. Okay, so the next question, it says given that a failure has occurred, what is the probability that the environment encountered was severe? So what is the probability that the environment encountered was severe, provided given that a failure has occurred? Okay. This was the answer to part A and part B. Okay, so the probability of a severe environment given that failure has occurred is the probability of severe environment and the machine failing over the probability of the machine failing. We've already calculated the denominator of this quotient, right? So we can write that down here. And we also know the probability of severe environment and failure happening, which was a 0.025. So we have a 0.025 over a 0.044, which is basically just a 25 over a 44, which is actually less than 1 because 25 is less than 44. But you can also write it in decimal places. And that's it. We're done with question number 2. Okay, the next. Suppose there are two boxes. Ooh, I hate these questions. But what I do is that I just always give myself, I actually hate probability questions because my mind kind of goes crazy when I have to think about the counting principle and the permutations and combinations. I don't know, it's never clicked with me. And that pigeonhole principle, they're very I don't know. I am somehow able to solve those questions, but I feel that I'm not really good at these questions. Okay, suppose there are two boxes. The first box contains 3 green balls. Okay, so I'm going to give myself a visual. that we have 3 green boxes here and 1 red. Okay, 1 red. And the second box contains 2 green balls and 2 red balls. Okay, 2 green balls and 2 red balls. Okay, suppose the box is chosen at random and then a ball is drawn randomly from this box. So first of all, I noticed that there's an and here. So there's one event happening and then the other event happening. So what my brain tells me is that the first thing is going to be related to the box that's chosen, followed by, and then there's something going to be related to the ball from the box being chosen. Since there's an and, therefore there's going to be a multiplication sign. Okay, what is the probability? Okay, so the first thing that happens is you can't actually get to a ball until you've reached a box, right? So let's just call this a box 1 and let's call this box 2. So either you will pick box 1 or you're going to pick box 2. Since there are just 2 boxes, therefore the probability of choosing box number 1 is just a half, right? Because there are 2 events and they have to add up to a 1. Random selection leads to equal probabilities. Okay, then there's a chance that you take out a green ball or a red ball. So then after you've selected a box, there are 2 possible colors that you can pick. So probability of green, given that it was box 1, is there are total 4 balls, right? And there are 3 green, so it's going to be a 3 by 4, which is actually a 0.75. And then the probability of selecting red, if you've chosen box 1, is going to be a 1 by 4, which is a 0.25. Okay. The next, if you had actually picked box number 2, then there was 50% chance, like 2 out of 4 times you would get a green and 2 out of 4 times you would get a red. So therefore we have equal probabilities here. So 50% chance of either of them coming your way. Okay. So what is the probability that the ball drawn is green? So there are 2 scenarios in which I could get a green ball over here from ball 1, or see, there's another possibility, or I could get a green if I had chosen box 2, right? So there are 2 possibilities. Let's write this down. So the chances of you getting a green are either you'll choose box 1 and then you're going to get a green. So this stands for an and, or this is an or, you're going to choose box 2 and then you'll get a green. A few tips that I would that I even tell my discrete mathematics students is that and is associated with intersection and or is associated with union, and when it comes to probabilities, and is associated with multiplication and or is associated with an addition. Okay, moving on. So we know that this is going to be you choosing box 1 and then you get a green ball given that you had picked ball 1. And the other possibility is that you chose box 2 and then you got a green ball provided given that you had chosen box 2. Okay, multiplying these, a 0.5 multiplied by 0.7 plus a 0.5 multiplied by 0.5. Okay, so a 0.5 multiplied by 0.75 plus 0.5 multiplied by a 0.5. So this becomes a 0.375. This becomes a 0.55 are 25, and we get a 0.625. So the answer is less than 1, so I'm happy. The next question is, if the ball drawn was green, so given that it was green, I know that given it was green, what is the probability that the first box was chosen? So what is the probability that the first box was chosen? Again, this is easy. The same Bayes theorem being applied. Given green, it means that probability of B1 and then you getting green over probability of green. We have already calculated these. It's a 0.625 in the denominator and a 0.375 in the numerator. We've already made this calculation. Okay, so the answer then becomes a 0.6. Okay, we've done question number 3. Oh, actually, this chapter only had 3 sample examination questions. There wasn't any 4th question. But the study guide does give us worked examples. So I think it's when it comes to mathematics, especially statistics, the trick to getting a distinction is just practice. So I'll solve a few more questions and I hope they'll be helpful to you. For now, take care and I'll see you in the next one.